Now we need to look at what does the law actually say about guards. And if you're working in the United States, the law that covers guarding comes originally from OSHA. OSHA is a federal law, Occupational Safety and Health Act, that's about workplace safety. And it is administered by the Occupational Safety and Health Administration, which is also OSHA. OSHA covers a number of places where a worker might encounter hazards, and the one we're going to talk about has to do with machinery. There are also OSHA rules related to electricity, and here they interact with the National Electrical Code. OSHA has specific colors that mean things. You might have noticed that extreme danger things are red. So an emergency stop button, a fire alarm, those kinds of things are red. A warning is what's called safety orange. And here are two pictures of safety orange. Safety orange has a precise color specification. And there is an OSHA standard where you can look up precisely how to mix safety orange. Here is the ASME standard for guarding. This is the safety standard for mechanical blah, blah, blah. And this ASME standard for guarding is the law because it is included by reference in the OSHA law, similar to what happens with building codes. So this ASME standard is part of OSHA, so it is the law. I should just say this one has been superseded by a later version, a 2019 version. This ASME standard says there are 5 places where you must provide a guard. A nip point is where 2 rotating things come together and you could get your hand or other body part squeezed. Now look at this belt drive here in the middle on the left side. You will notice that on the bigger shiv, there is a nip point at the top. If you stuck your finger in there, you'd get sucked into that spinning shiv. However, at the bottom of that big one, there is not a nip point because if you stuck your finger in there, it would just spit you out. So depending on the size and configuration, you might not need to provide a guard all the way down to the bottom of this larger shiv. You might just need to cover the little one and the top half of the thing. It's the nip point that you have to cover. Here are 2 more examples. A shear point is where moving pieces are sliding past each other and they could, chop something off, like a pair of shears cutting through paper. A snag point is dangerous if you have long hair or loose clothing or long sleeves on your clothing or anything. If these things are not guarded, they can catch your hair or your clothing and suck you into the machinery. So they have to be guarded as well. There is such a thing as guarded by location. And according to this ASME standard, moving equipment that is at least 8 feet above the floor is considered guarded by location. So for example, if you had a conveyor overhead up here in your shop, and it was at least 8 feet from the floor to those moving parts, you would not be required to provide a guard for that. What is a little bit troubling about that is that does not protect tall people. There are some people who are, let's say, 6'7" tall with long arms. They would still be able to get their hands in there. So I don't know. If it were me, I would still guard it. This is the chart for distances out of the ASME standard. It's pretty hard to read, and the numbers are in millimeters/inches, so I photoshopped it. Here's the Photoshop version. I photoshopped out the millimeters, and here are just the inches. And here is a picture that tells you what each of those letters on the chart represent. So this is how you can figure out how high and how far you need your guarding to be. For example, let's say you have a barrier, could be a guard or something, and that barrier is 48 inches high, and the distance from there to the moving parts is 36 inches. How high above the floor can the moving thing be? So if the barrier, that's dimension C. So here's dimension C. If it is 48 inches, dimension C, and if the distance from the barrier to the moving part is 36 inches, so here's distance. These numbers are D for distance. In the column for the 48-inch barrier height, here's the 36-inch D distance. Then, going from 48 down to there, now going over to the B, how high does the moving thing have to be above the floor? So there's the B on the picture. This column is the B numbers, and according to this, the equipment must be at least 78 inches above the floor. I grant you this table is not user-friendly. When you have barriers in front of something, like a guard with expanded metal, how far away can the moving thing be in order to protect someone? So if this is expanded metal, you could stick a screwdriver or a finger through that expanded metal. How far away does that spinning thing have to be? So here is the expanded metal, and it's saying if the bigger opening is A, so here's opening A, and let's say you have a guard where the expanded metal has 1 1/4 inch opening. Okay, how big is dimension B then? B is how far is it away from the guard to the spinning thing. Dimension B. And according to this bar chart, if the opening is 1 1/4 inch, then the moving thing must be at least 12 1/4 inches away. Again, this is not very user-friendly either. Here's an illustration. This is not the ASME standard, but I think it's a useful picture, so I stuck it in there. Now, some other types of guards that you can see or consider using yourself. An interlocked guard will turn off the power if the guard is removed. Here's another example. You find those on things like, here's a plastic injection molding machine, and inside this yellow thing, that's the caution yellow color, inside the yellow thing is moving mold holding equipment. So there is a limit switch on the side of this molding machine. Here's what a limit switch looks like. When that guard is pulled open, it trips the limit switch, and that shuts the power off to the machine. Here are some other examples. A dead man control, that's a creepy name, but that's what some people call it. The basic idea is if the person is not conscious, the switch cannot be on. And you might have seen a dead man control on a lawnmower, for example, where you have to grab a grabby bar on the handle for the mower to go. And if you let go of the bar for whatever reason, the lawnmower stops instantly. Well, you also see it in things like, here's a press brake for forming sheet metal. This is at Peterson Pacific. Here on the floor behind the press brake operator is a foot switch. That's a dead man control. So he has to be consciously stepping on that switch with his foot in order for the power to be connected. They look like this. If he or she is not activating that switch, then the power is off. Another version is basically the photoelectric cell, where light beams, you see this in movies and art galleries and so forth. The light beam is a curtain, and if somebody puts their hand through those light beams, that turns off the power. There are some more examples. Finally, we mentioned that OSHA interacts with the National Electrical Code and controls electrical hazards. I just mentioned this device called Lockout-tagout. You may have seen this in action. You may have actually done this. And this is required when a maintenance person is working on equipment. And what happens is there is a red tag and a padlock that has a key. And this is an example out of this is the central plant. These are some breaker panels in Lane Community College. So with Lockout-tagout, more than one person has a key to the padlock. So if you're going to work on this object, you turn off the power, you put on the padlock, and 2 people or 3 people or however many each get a key. You need all the keys in order to start the equipment again. And if one person is missing, you cannot open that padlock and you cannot start that equipment. And you can easily imagine what that's for. There could be a situation, if you didn't do this, where, let's say, one person used their key to open the padlock, another person was missing, but that was okay. So the first person opens this up and turns on the power. Well, the second person is missing because he or she is around in the equipment working on some gears. And if they don't know that, and this person turns on the power, the person working on the gears gets badly hurt. So you need more than one key. You do hear irritating stories of where people will do lockout-tagout at the end of a shift, and then one of the people goes home with the key in his or her pocket, and then you can't start the equipment until you call them and get them to come back. All right, anyway, there we are, guard.